the basics. Base. Base 6. Big the basics. Base. Alrighty, TCRS is 8th, even though he's the first one here. Base! Let's get down here. Get down to the get down. What's up, Nate? I'm going to let a few people get in here, and then we're going to talk about some basics. Some basics! Michael loves the basics.
Basics.
Base. 6.
Basics.
Basics. Biggity basics. Okay, but wait. So, this board's already been scavenged for some parts, but it is still a good learning tool, and we will use it. So, what we're going to do... Well, we're not going to be working on much today. I had a few I'm going to talk about, and I'm going to talk about the PMIC phones that we had, and we're going to discuss some basic stuff on these phones. I've had a few people ask, what's up, Miles? Ask how I measure things and how I tell if they're good or if they're bad or whatever. So, I'm going to go over the basics on what I test, how I test it, yada yada yada, and if people can learn from it, they can learn from it. If not, sorry, I tried. Tough titties is what Micah says.
Tough titties.
Okay, so I'm going to go over the basics first. We're going to do how to tell if a cap is good or not, how to tell a short on line, how to meter a resistor, how to test a filter if it's good. There's some parts of testing filters you can't really do with like the actual inductance, but we can at least meter their continuity. Offline on my iPhone on LTE. We're going to meter, like tell what different type of filters there are, what different type of coils there are, what type of capacitors, what type of resistors, blah, blah, blah. I'll try to go over as much as I can if you have any questions. And I don't have all the answers, but this gets me far enough that I can fix most phones. So it must be enough information to suffice, I guess. Micah testing titties.
I'm over here testing these tough titties.
Micah's testing tough
Chris's
titties.
mama's titties.
That's not very nice.
Oh, you about said it too. I heard you. My mama's titties.
Man, you full retard. Stream running? Yeah, stream's running. Are you running? Is your refrigerator running? You need to go catch it. Alright, so we're going to start out just general... Oh, I forgot to mention diodes. So I'm going to use the backlight circuit because it has a few of our components, and I'm also going to come up here and check that this one has a resistor, a few resistors actually. We'll also go find some other resistors, that way we can kind of tell. So first we'll do the backlight circuit. So I've removed the driver from this one, which normally sits right here on the 5C. We removed a few components. This is a parts board, so it's been scavenged for necessary parts. But anyway, so first things first, you want to test so let's say we want to test a line that has a short on it. And we might have a bad capacitor. Let's see if this capacitor is bad that we found laying over here. This might be bad. Not sure. No, that cap's good. Well, anyway, so a capacitor in most cases, except on audio ICs and sometimes for decoupling caps for internal AC frequency cleaning. And a good example of that is here on Chestnut. You see this cap here. It's C54. It's just a 10 UF cap. And it's connected to CP, which is probably Chestnut positive, and then Chestnut negative. Chestnut has an internal boost circuit, so it requires some type of way to clean the voltage up. So it uses a negative positive line internal to itself, and it runs it through a decoupling capacitor that sits outside of the chip because it's too large to sit inside the package. And you'll notice that these decoupling capacitors usually are fairly large. So this one's a 10 microfarad cap, so it's fairly large, and that's why they can't put them internal. You also see this on the boost circuit for the backlight. So here, instead of the boosting being internal, it actually has an external boost circuit using the coil and the diode. But it also, here you look and see on your output, you have a 2.2 UF, 2.2 UF, and 2.2 UF. So you're adding up to almost, I mean, you're close to 10 UF again. And then you also have a what looks to be some type of D-sense. I've never seen that one. So it's got some, it looks like a voltage divider setup, but it's actually two capacitors, so it may be some type of AC wave like reduction or something. Let's see, stacked to meet voltage requirements. Look, 18. Oh, okay. So these are actually stacked caps because they are required to read 18 volts, and the caps are only rated for 16. So interesting that they kind of made a little bypass there. But anyway, so back to this. These capacitors, the way you would normally read them, instead of a decoupling situation like this, which is not normal, you'll normally see them like this, where you'll have a cap with one leg on the positive and one leg on the negative. And capacitors do not pass DC current. So if you meter one side of the cap to the other side, these should not pass any DC current. So when you use your multimeter in continuity mode, which you can hear it there, the meter is actually outputting a voltage, and it's looking for that voltage to make continuity all the way through. So when you touch either side of a cap, if the cap is good and not passing DC current, it won't beep because there's no continuity through it. Here you go, Micah. So what normally happens on lines that are short is capacitors will normally go bad. And what happens is, instead of having a separation from your negative to your positive side, which these are non-polar, but they have an anode or cathode, they don't pass DC through, you'll get a beep continuity through the capacitor, which takes the positive side of this cap, which may be, as example here, it may be on the 5V7 Sage. Well, actually, we'll do it on the 6 volt because this is a negative rail here. The PP 6 volt LCM boost line. If the boost side, which would, let's hypothetically say it's on this side here, like this is the positive side and this is the negative, as voltage comes along and it hits this cap, if there's a path to ground, voltage will go there. It does not give a shit where you want it to go. It's just looking for the simplest path to ground or way to complete a circuit. So that's kind of how electronics are manipulated. You're essentially taking a voltage and putting it on a line, and then if you want it to do work, you give it a path to ground through the item that you want it to do work for. So, for example, let's see here. Oh, a good one is the backlight circuit. So the backlight circuit is kind of a way to trick voltage into going the way you want it to go. So what it does is you have a voltage coming in at VCC main, which is usually 3.8 to 4.2 volts. It's coming along here, and this inductor has some resistance. You can see the resistance here. It's 0.876 ohms, and it has a current limit that the coil can handle. So the voltage comes through here and goes through the coil, and then it goes out, and it goes through this diode. The diode is a check valve, so voltage can flow through this way, but it can't here. It hits this gate almost and stops it. So as voltage comes through here, it'll pass on through to the anode, which goes out to your backlight. Well, what this circuit does is it's directing this voltage through and out to your backlight. The backlight has an output that comes back through the cathode lines, which supplies a feedback for the chip, and it also gives the backlight a source to ground through those. So what you're getting as this passes through here, the boost circuit will start to take voltage as it goes through the inductor, and it'll pulse it to ground through the switch line here. So where it says switch, that's actually a tied switch to ground inside of the IC. So it tricks the electricity by pulsing it to ground really fast, which causes this electricity to rush in through the coil, but the coil wants to stop that rush of inrush current. So what it does is it builds up a charge on the actual coil, and when it does that, it increases the voltage that's pulled through this line, and then when this switch turns back off, the voltage gets through here, and it's already moving fast, so it wants to keep going, so it runs through the diode, and then once it's through the diode, it can't go back, so it's kind of stuck at a higher voltage past the diode. So that's just kind of how the boost circuit works. But in general, back on topic, the capacitor is a one-way. It should not be passing DC current through. It is used on audio chips, and it's used as decoupling. On the audio, it's used to smooth out and block any DC interference. It allows AC current to go through, but it does not allow DC current to go through. So when metering caps on boards, in most cases, especially on shorts and stuff, you're going to be looking, if you're trying to find a cap that's bad, when you pull the cap, you're going to meter one side and the other side with either diode or continuity mode, and you should be looking for a capacitor that does not beep. So on this one, in case, we can meter that and there's no beep there. So does anybody have any questions on that part? And we'll move on to the next one. See, any questions? So for the capacitors, when they're out of circuit, if your meter has an option, there's a section that will give you it'll be a setting for capacitance, and if you go to that setting, it'll be reading in nanofarads. So when you meter the cap, it will actually put a charge across the cap, and it'll tell you how many farads this cap is. So this one's reading right under 2.1, looks like microfarads. So 2.1 microfarads there. So that's what that cap would meter. Now, if we were metering that, we would come over here and say, well, this one says it's supposed to be 2.2, but it has a 20% tolerance. So if you look on your cap, it says here 20%. They have a tolerance rating, so 2.2 is probably well within the tolerance range. And as long as it's within that range, you're good to go. So if you think a cap is suspect and it's not fully short to ground, pull it off, meter it, and see what it gives you. This one is well within spec. I actually think this is a backlight output cap, so that measures right in spec where it should be. So metering resistors. Let's find a resistor. Resistors are fairly easy. Now the only thing about a resistor is you have to hold your meter probes pretty straight. Let's see here. R61 seems to be there. So we're going to find this component. Let's see, not found. Alright, why are you not found? Maybe it doesn't exist. Doesn't say no stuff above it, but it might be no stuff. Let's just go and see if we can find another resistor. Resistors are fairly easy. Like the number that you read here, so this resistor is rated for 0.00 ohms, so it's pretty much just a fuse. So the same way you meter a cap, you'll meter a resistor. So let me see, I'm just going to find one on the board and we can measure it. Usually they're fairly small, so one of these is a resistor. So we're going to put our meter in resistance mode, which looks like the little horseshoe shape for those that are following along. And we're going to just put our probes. Doesn't matter which direction you put your probes, you're just going to put it on either side. So we're metering that cap and that resistor, and it's reading 99 kiloohms. 99.8 kiloohms. So that's probably a 100 kiloohm resistor. And all you're wanting to do is just meter those and see, like, you want to see if it's within spec. So the resistors have a tolerance spec too. Some of them may be 5%, some of them may be 0%, but as long as they're close to that reading, you should be fine. If they're way off, then you know there's a problem. So that's pretty much how you meter resistors. Sometimes you may have to pull them out of circuit, but it's fairly straightforward. Again, doesn't matter if I put my probes this way, I get 99.9 kiloohms. If I put my probes this way, which is the opposite sides, I get 99 kiloohms. So it's pretty much the same. Doesn't matter which way you read it. Capacitance has to usually be done out of circuit TCRS. It's hard to do in circuit. There are some that are specifically made for in circuit, but I don't have that one. Yeah, I agree. TCRS is saying that most of the times you don't have to meter caps, capacitance if they're not shorted, they're usually okay, which is true in most cases. Sometimes you can have some caps that are out of spec, especially on like backlight outputs. They're there. They have to have a certain capacitance to smooth the power coming out. And if the power smoothing isn't correct, it can cause weird issues with the boost circuit, causing the IC to overcharge or boost too high because of the interference on the line, and can cause some really bad problems. But in most cases, most practical applications to this is, in the words of Jessa, you won't need to meter the capacitance, but you will need to make sure that they're not short. So let's see, what do we got next? Let's meter coils. Coils, filters, inductors, whatever you want to call them, they're all the same thing. So this right here, L19, is what we consider a coil, and on the schematic it's drawn as a coil. Let me see if they even draw the filters as a coil. I don't think they do. Oh, they do. So that's a filter, FL16. And then if we go back though, let me see. Gotta zoom back out. That's an audio driver. So L19 is a coil, and FL, whatever the other one was, FL9 or something, that's a filter. So 10 kilohertz oscillator needed normally. A cap can be partially shorted if dielectric is damaged, but not enough for dead short. Marway, that's true. So, or Marway, that's true. A cap can be partially short and not actually be completely shorted, and in those cases, it's a fucking nightmare to find most of the time, because the cap won't get hot if you inject voltage, and sometimes the foam will even work. It'll just have a partial short that's drawing too much current and will drain the battery. So it's really hard, like really hard to do. When you have like a partial short, things it's just, I've had boards where I've had to pull every cap on the line, every IC. Eventually you find it, but it's not worth the hassle in most cases. So anyway, so let's meter coils. So coils, we're not really going to worry about, is our inductance okay? I don't personally know. You have to have something to meter the inductance, which I don't think the standard meter will. But normally on those, you just want to meter your continuity to make sure that it's still good. So you'll put one side, doesn't matter which, on one side of it, and then the other side, and see if they beep. So that tells me that this inductor is okay, and the ohms across that are, it's 1 ohm and falling. So it's reading about 1 ohm, which is normal, because if you look at the ohm reading across some of them, they'll be close to that. Like the backlight here, it says it's supposed to be 0.876 ohms. So we're reading right at 1 ohm. So the meter isn't super accurate down to those sizes. It reads between 0.9 and 1 ohm. And my probes alone have 0.3 ohms resistance. So you've got variables in that itself. So that's pretty much how I meter filters, and there's coils. There's multiple types of them. So you've got a coil like this, and then when you talk about filters can look like this. They look like a capacitor or resistor, and they will meter the same though. Hopefully that's not a capacitor. No, that's a filter. So same way, I'm just metering across the filter, and it's metering 0.6 ohms. And then these are also filters. These are two-sided filters. They pass through data for the LCD output. Same way, you meter those the exact same way. You don't meter them across like this. You meter them straight across the actual filter itself. So inside here they have individual windings for the inductance. And that's just to clean this voltage line up as it comes through. So same thing on all those. What can I do for you?
We called about an iPad screen.
Okay.
I think this is the 2. I didn't want to turn it on to check the specifics of it since it's shattered, but
Yes.
okay. And it was 60, I think.
Mm-hmm.
Should I pay you now or want to pick
When you
up?
pick it up.
Okay.
If you don't mind, just fill that out for me, and we'll get it taken care of for you.
About how long does it typically take?
Based on today, it'll probably be ready tomorrow sometime.
Oh, great.
Bet you do a lot of them, huh?
Oh yeah.
Yeah.
We do quite a few.
I literally just finished one up.
And it seems like it's working properly, but if you get it, do you guys check that before you fix the glass to make sure it's...
We'll check them out before and after.
Okay.
Which ones do you do most, the iPads or the cell phones?
Cell phones more so.
Probably, yeah.
People use cell phones a lot more.
Yeah. Luckily, I've never done that to either my iPad or my cell
So it's both.
Yeah, definitely knock on wood on those.
phone.
Usually a matter of time on that stuff.
Well, this was the work of an 8-year-old in a concrete patio.
We had one that a lady brought in, and her was it her son?
She got it. It was her grandkid.
Yeah, she got it fixed.
They busted it the first time. They threw it on the ground and busted it. And then as soon as we fixed it that night, I guess they were watching their dad, use his tools and stuff. So they took a little plastic mallet and started smacking the iPad.
No!
I don't think I'd be paying to get that fixed.
Started smacking the screen.
Sorry.
Wow. Jeez.
So yeah, it was quick turnaround on that one.
Yeah, I don't think I'd give it back to him until I grew up a little bit.
Too bad, so sad. Natural consequences, they say.
Yeah.
Okay, do I just leave this then with you, and that's all?
Yes, ma'am.
Okay, thank you much.
No problem.
When it's ready.
Y'all have a good day.
You too.
Yeah. We need to do inventory on iPad screens today so I can order.
Well, here, you probably need this one. This one sets.
Let me make sure it's working. It should boot right up. It's been charging.
I turned it on already.
Yeah, it's charging. Alright, cool. You can put it back there. I gotta take him a bunch of stuff anyway.
Tonight?
No. I'll have to do it tomorrow, I guess. I need to take this iPhone 6s screen to him sometime tomorrow. Okay, so next thing we're going to go over is if you all have any questions, please ask them. But the coils, inductors, or filters are all the same thing. So if you ever hear somebody say coil, inductor, or filter, that's what they're talking about. It's going to look like either a coil, a filter, or an inductor, or something along these lines. Also with capacitors, you'll see some things like these. They look like diodes, but sometimes they're actually capacitors. So they're shit, what kind are they called?
What's wrong with this?
It's terrible, I can't remember. It just didn't, she said it didn't power on. It could be not charging. Fucking, what are these caps called? I can't, we just looked them up the other day. It's the type of cap it is. You have ceramic caps, which are standard now, but you also have this one. I've got to look it up. It's going to drive me nuts. Let me see. I can actually look it up on the schematic here. So, let's see. Is this cap? Yep, it's cap. So it should tell me what this is. So it's a tantalum. That's what it is. Duh. Couldn't remember. So if you look here on the schematic where it's highlighted, it says 20% 1UF 25 volt tant. So it's a tantalum capacitor. I'm still not sure why they use tantalums, because all the research that I found is the only difference is the tantalums are once cheaper to make, but they don't use them on all the spots. If it was a cheaper option, I would think they would use them more often, but they rarely use them.
Tantalum caps had a higher heat rating.
Nope.
Did they not?
Nope. Tantalums have a lower heat rating. They have a higher ESR, which means you have more voltage loss.
Yeah.
They don't discharge or charge as fast, and they cost the same amount to make now, and they take up a larger footprint. Yeah, and they take a larger footprint now. So I'm not sure as to the purpose of it. The tantalum's lower ESR, it's not what I've heard on the new ceramics. They're not. I know it used to be the tantalums were lower ESR, but I had heard now that ceramic technology had caught up with it. But anyway, so this is also a capacitor. It's just the tantalum. You'll hear Lewis, if you watch his stream, he talks about them. They fail a lot on the MacBooks. But just an idea of what you're looking for. Alright, so next we're going to move on to is a diode. So right here, and on the schematic it's labeled as D1. Diodes will be listed on that like that. And then let me switch over to schematic. On here, there's D1 right there. So that's your diode, what it looks like on the schematic. And you can also have a Zener diode, which has the marking DZ. This one's no stuff, but normally on outputs and stuff, you'll have a DZ or a Zener diode that takes any high voltage coming in and shunts it to ground. So a diode technically is a one-way gate, but some diodes, like Zener diodes, are designed to allow voltage through to pass if there's too much current input. So this one's rated at 2.5 volts. So if something coming across this line is higher than that voltage, it will allow it through. Actually, it's 12 volts. So anything higher than that, it'll allow it through. On a normal diode, though, they also will allow voltage to pass back through them, but they normally only do it if it's a certain amount. They're not meant to backfeed. Let's see if I can get back to where I was. Alright, so here we are. So diodes. So the way they work is you should have voltage coming through this direction, and it should go through the diode, but it should not be able to pass back through. So on your meter, you're going to want to put your meter in diode mode, which looks like, it looks similar to this. It looks like an arrow going towards a plus sign, which this kind of does if you look at it and take off the ends here. It looks like an arrow with a plus sign at the end of it. So we're going to be in diode mode. And the way this should meter is one side should allow voltage through, which you'll see on your meter. So we need to reverse them here. With a properly functioning diode, one direction will give you a voltage reading. So this gives me a voltage reading of 0.18 volts pass through. Now if I switch, which I have my red on my right and my black on my left, if I switch these, so they're switched now, and I meter this, I now get a reading of OL, which means that this diode is not letting the voltage pass through from this probe to this probe. But if I switch them the other way, the red being the positive feeding the voltage out, it will allow the voltage to pass from this red probe through the diode to the black probe, which is our negative, and we get a voltage reading. So what you have is on the schematic here, the anode side allows the voltage to come through and go through the gate, but the cathode side does not allow voltage to pass back through it. In most situations, that's how this will be designed. Zener diodes are made to allow voltage to pass back through, but it has to be a high enough voltage. What your meter will put out probably won't feed back through it. It takes quite a bit more. So when you're metering most diodes on an iPhone or an iPad or MacBook or anything, they should feed voltage one direction and not the other. Now when the diode itself fails, sometimes they can fail where they're completely open, so it won't pass voltage either direction, or they can fail where they're completely closed, which means that voltage can pass through them both directions. So you should always have no pass through one direction from this side to this side, but you should have pass through from this side to this side. And if you look at the diode itself, hopefully this is in focus. If you look at the diode itself, it always usually is marked by one side having a stripe on it, which this one has it here. And that's the side where the cathode is. So the voltage comes through here, goes through, pretend this is a wall, and it goes through here, but then once it goes through the wall, it can't come back through. So this line indicates where it's going to stop the voltage at. Diodes don't always have that. On the newer ones, they have some that don't have the stripe on them. So that's something to keep in mind, but that's one way you can tell on backlight diodes usually which one is, or which side is which. I also noticed here this is a different style inductor. You'll see this on the newer iPhones mostly. They use these are it's the same design as this, but instead of having this formed core, they use like a pressed metal, like epoxy style thing that has the coil inside of it. I can actually break that one apart so you all can see the coil in it. This is how I normally break apart the iPhone backlights. So I'm going to let this heat up. And we can actually break into this coil. And you can see the coil wire in it. Alright, so we've dug down into that some. And if I start to excavate this, see the coil of wire right here? It's actually wrapped like this. It's wrapped around this little core of just epoxy stuff that holds all these little steel pieces together. If you look in there, you can actually see the flakes of metal. See the metal flakes in there? You actually can see, if we clean this off, you can see the coil of wire there. So that's the inductor, that's the inside of it. And actually, if I dig in here, I can pull those strands of wire out. Well, or knock it completely off the board and lose it forever. But anyway, so inside of that, there's just a coiled wire. If you come over here to this inductor, it's the same thing. We can actually break the end caps of them off sometimes. Usually they fall off for me, but of course, there it goes. So let's see if we can get our scope. Well, there's our inductor. Let's see if I can get this in focus for you all. It's hard to see when I'm at an angle because I'll just have to break the top of the coil off so you all can see it.
Before I get blamed for it, she has a crack in her digitizer.
Okay. So as
looks like it's chipped there and cracks down through here.
Okay.
It's very small that you can barely see until you tilt it in the right light.
Okay. So as you can see, this is a metal core here, and it's got wire wrapped around it. And there's the wire core that's wrapped around it that creates the coil. Looks like a shoddy diode should mention different voltage drops. Why does it look shoddy? That reading is normal, like 0.18 volts. Shoddy diodes usually mean that they're not letting the power through correctly, and if they backfeed through themselves when they're not supposed to, usually it means bad. But anyway, so going back to the inductors, that's kind of what you're looking for. It's got this coil of wire inside of it. You can actually pull these coils of wire apart, like see all the strands of wire in there. And what can happen is when you do this and you break them, if we come back here and meter this, that wire should be coated, so that should break the inductor. Let's see, unless it's not coated. Okay, see now the inductor doesn't read across properly. So if I touch here, it's good, but if I touch here, nothing works now. So coils can fail internally. They can also, as you see here, this is coated wire. So this wire has a plastic coating on it, or I mean, it's not really it is a plastic. It's a type of plastic. I'm sure somebody out there will be like, well, it's not a plastic, it's an enamel coating, but whatever. So there's a protective coating around this wire that keeps it from shorting to the next wire next to it. What happens sometimes though is on backlights, especially on the iPhone 6, if a current rush comes through this coil, it will heat these wires up to the point that the coating on it melts and they will touch each other. And when they touch each other, that causes a shorter path through the inductor, and having a shorter path through the inductor will end up causing lower inductance, and you'll have a lower voltage increase through the boost circuit. So what you'll see on the iPhone 6 sometimes, let me see if I have one that hasn't been mutilated. Most of mine have been mutilated. I'm sure this one has too. Okay, no, it's still here. So this is a sealed coil, just like the one that was over here, except you can't see the top end caps. You can only see the bottom ones. So pretty much this is the same thing as this, just different package style. So there's the old package style that we had here, and then there's a different package style. These are all here are different coils. But what happens is when this heats up, that coating in there has nowhere to go. It expands, so it'll actually break out of the top of these, and you'll see what looks like coil shit that pops out of the top of them. So that's something to look for. And when that happens, what has happened inside is the wire coating that's on the wires in there like this has actually expanded and melted, and it's now created a lower inductance on that coil. And by having a lower inductance on that coil, you're not going to get a high voltage increase that the backlight will try to produce, and thus that leads to a half-dim backlight, or a backlight that gets way too dark. Like you can turn it up, but then it doesn't go all the way up, and then if you turn it down, it gets way too dark, and that's because the voltage being put through is not high enough. So Leslie's talking about something, I don't know. Talking about the non-practical use of this information. I mean, I understand, like, this isn't all going to be correct, and I'm not a fucking electrical engineer. This is just how you can generally understand these things. There's going to be differences in them. You were saying that it should be 0.7 volt drop. If I put my probes let's see. We'll do a different diode, just so I can kind of show you what I get. So output to here is the same, so that's a 0 volt drop. And then input to input here. So metering off the back of this diode directly through the diode, I get 0.19. So, I mean, for my meter, that's normal. 0.189 and 0.19 are the same reading pretty much. So I don't see that as a bad reading. Maybe it is in some other sense, but just based off of how my meter works, that's normal for mine. But anyway, so that's kind of how diodes and how coils are. And let's go on. So on the chip, or on the schematic, you can see diode is D1, coils are L3, or inductors are L3, whatever you want to, or they start with an L. Diodes start with a D, capacitors start with a C, resistors start with an R. You'll have some different type of resistors that will have RF, which is radio frequency, so they may have resistors that are marked RF. They may have ICs marked that as RF. Those are all just radio frequency components. They have to do with the cellular signal. Here's one to look for. The marking as Y. Y is a crystal or a oscillating chip. So if you see a Y indication, so on the iPhone 5C, the Y2 chip has to do with the timekeeping for the PMIC. So Y2 crystal can go bad. Sometimes you have to replace it. The crystal chips are very sensitive to heat, so you have to be mindful of that. Another thing you'll notice, ICs or IC packages on schematics will be labeled with a U. So we have a U11 there, and then if you go up here, the PMIC is rated as, or is listed as U7. Here's more filters, FL. There's R's. I'm trying to see if there's any different ones. XW normally just means that's a trace connection. You won't be able to really see those usually on the board. Sometimes you will, but not all the time. So if you see a XW on the schematic, chances are you're not going to find it, so there's no sense in hunting for it. You look here, J1. J usually means a FPC or a connector. Here you can see those double inductors I was talking about. These are for the camera, but it's still a data line pair. So you have a data line negative and a data line positive, and they go through an inductor here, which is a two-sided inductor, and runs into the FPC. One we skipped over, Q is a Mosfet. So you have N-channel and P-channel Mosfets, and the difference is one of them, the gate voltage will be higher than the input voltage, and the other one, the gate voltage will be lower than the input voltage. So depending on what type of MOSFET you have here, as the voltage comes in, if this gate voltage is lower or higher, depending if it's P-channel or N-channel, the voltage here will be stopped if this gate is not active. As soon as this gate goes active, depending on which one it requires, it will connect the source to the drain. So it actually comes through from source side, which is ground here, to the drain side, which is the output here, which looks like it's some type of controlling setup. Okay, so it's a proximity thing. So this turns the display off depending on what the proximity is saying. So it either can send a ground signal or a high signal. So it's just a signal line. Another way that MOSFETs can be used are in this case here. So they can be used like a breaker or a relay. So the PMIC here has a control line, which is CPU 0 switch control. It comes out here and it goes to the gate here. You have a 1.1 volt signal coming in, let's see, source. Yeah, so this is your source input. The gate is controlled by the PMIC. PMIC can close that, or open the gate technically, but close the link here and allow this source to drain to come through and go out onto the different lines. Actually, it's source is the output. Excuse me, I'm backwards. Drain is your actually feed. My bad. So that's just the different ways that those MOSFET work. Trying to see if there's any other components that you all might be run into. There's a bunch of different ones on the MacBooks. You'll see some like PR, which are different type of resistors. Let me see if there's any PR here. What the fuck did I just disconnect? PR. It might be RP. I'm not sure. It's one or the other. That's no problem, Bobby. Where the fuck is my mouse? Sometimes my mouse goes missing. I'm not sure why. Is it on? I don't fucking know what's going on right now. Oh, my mouse has been disconnected. How the fuck is my mouse? That's turned off on my trackpad here. Oh, there it is. How did I do that? For some reason my trackpad's disconnected. I'm not sure how I did it. How did I disconnect my trackpad? I've disconnected my trackpad somehow. How did I do it? Does anyone know? Anyone know the hotkeys for an HP to reset the trackpad? This is crazy. Let's look this up. Shut it off in the tray. Yeah, I don't see the fucking hotkey for it though. There's one that looks like it, but that's not it. Function F7. Let's see. That's volume for mine. Poly fuses? No, I have not yet. Let me see here. HP ZBook track touchpad on off. How to deactivate the touchpad. Right click advanced first. No, that's not it. Top left of the touchpad, there's a tiny dot. Double tap here. Holy shit, didn't know that.
What is it?
There's a fucking small little LED in the top left. If you double tap it, it turns the trackpad on and off. It fucking blew my mind. Whatever. Bobby just said it too. Bobby, you're a genius. Alright, so talking about fuses, let me see if there should be a fuse on here. I don't know if they have fuses on the fucking MacBooks or not. Or on the MacBooks they do. I don't know if they have them on iPhones. I don't think there's a fuse per se. So they use a resistor or a filter in most places of fuses on this. Here's another one, PP, which we know what PP is. You don't want that in your mouth. But anyway, PP usually is a test point. So if you see PP on a schematic or TP, it's a test point location. I'm still scrolling through here to see. Mind blown emoji. I do need that right now. As far as fuses go, fuses are normally listed as an F on the schematic. So if you have a fuse blown, the easiest way to check those literally is just 1 meter put your meter on continuity mode, and doesn't matter probe orientation, just touch both sides. PP is what you find in toilet water. That's very true. Let's see. Here's something interesting that you all may need to know. Every now and then you'll hear of somebody say pull up or pull down resistor. So lines have resistors on them that are data lines that use a pull up or pull down resistor to send a signal. So on these AP I2C lines, they have pull up resistors that pull the line up to 1.8 volts. And the way data is transferred across these lines is they actually pulse to ground, which creates a blip. If you look on an oscilloscope, it actually creates a pattern that you can actually look at and see the actual blips in the voltage. And it pulses these 1.8 lines to ground to make a signal. They put these resistors in place though, because if you had 1.8 volts here and you just blip this whole line to ground, it's going to pull 1.8 volts anywhere on the board to ground. So you need to make sure if you hear that, you kind of know what they are. So pull up resistor or pull down resistor. Pull down will pull the line down to a certain either voltage or ground or whatever. Pull up resistor will pull it up to a voltage or whatever. So if it's a pull up resistor, the circuit is a big kid now. That's true. So pull up, it makes the line on the voltage on the line higher. Pull down, it makes it lower. Can also make it ground. But that's, if you ever hear pull up or pull down resistor, that's all it is. You can also have a pull down resistor. I think is usually used for keeping a line from being float. It keeps a line from having any residual voltage on it. That way, whenever the line is technically off, it won't sit there and have just static voltage sitting on the line. It'll pull that line to ground. I don't think the iPhones have many of that pull down resistors. I know they have pull up, so they may have a few pull downs, but I don't think they have many. And again, I'm not an electrical engineer, so there's situations that I'm sure somebody could be like, well, just look at this chip, it'll have one because it's required, and that's probably true. I'm just going off of what I know and understand. What I was talking about earlier with the RF stuff, so if you look here, you've got U2000 RF, and then if you look at your resistors here, which they're kind of jumbled, but it says RF 232 RF. And that could be just because of the fucking overlap here, I'm not sure. I mean, it says RF here also. But any of your signal lines for cell signal or anything, or Wi-Fi or Bluetooth or anything, are going to have an RF indication. So this is a standard inductor or coil. But since it's used with cellular front-end 2G, since it's used with a cell signal, it has a designation at the end of RF. So it doesn't mean that the coil is any different than a coil that you find somewhere else. You may be able to find a coil that has the same rating that's used somewhere else. You can interchange those, but usually the RF stuff is much more precise. It has to be for the application it's used. So most of your RF stuff is going to be a little different than your standard board components. Well, let's see. Is there anything else y'all want to talk about? I don't know of any resettable breakers on these boards. I'll tell you one thing, if you put too much power into a PMIC, it'll fuck it up. What the fuck is that? Oh, it's a connector. I was like, what the I thought it was something else. There was one on the FET. Oh, okay. Well, that would make sense for the Mosfet. You don't want it floating and sitting there just letting power through when it doesn't need to. Alright, so in general, that's how things are. To meter MOSFETs in function, You can do it with continuity mode. When the MOSFET is open and working, you can meter through and see it. Usually, though, the easiest way to tell if MOSFET's working or not is just meter the output and see if you're getting voltage and if that voltage matches what you're supposed to be seeing. MOSFETs can be used in several different ways. They can use to be as a on-off, just gates open, gates closed, faucets open, faucets closed, whatever. MOSFETs can also be used with a controlling IC to be pulsed. Let me see if we should have one. On the MacBooks they have them. I don't know if they have them on iPhones. MacBooks use two MOSFETs. They'll use, it's what they call a buck converter. So a buck converter takes a DC voltage and it converts it. It's a DC to DC converter. So it'll take a lower DC voltage, and by using two MOSFETs in series, or not series, they would be in parallel, on the same line, you can actually boost voltage with them. Let me see if I can find one. I don't know that the iPhone uses any external buck converters. They mostly use internal. No, that's not it. I thought that was it. Let me see. Buck converter, buck converter, buck converter. If I have to, I'll just open up a Macbook schematics so y'all can see it. That's an on-off gate. That's not a buck converter. It's only one MOSFET. I also kind of need to... Jess had talked about this the other day, but you also run in for the cameras. Let me see if this one has it. You have what they call an LDO. Low voltage dropout. So an LDO is used to make a clean, lower voltage output for precision things such as cameras that need to have a clean power source. They can also be used for other things, but where are we? So accelerometer, no. Camera connector, no. Well, I don't know if it has on this. Let me look it up on the iPhone 6. What we'll do is 6 Plus. That works. Alright, so let's look for LDO. See if it just come up under that search.
Hey, is it alright if I run up to connect, take a music, get my giant coil?
Yeah.
Since you're talking about coils.
Yeah, go get your coil.
Alright. I got that thing running Malware Lights and that iPad's opened up right now.
Okay. Alright. Front camera. Where's my 2.8? I suspect the LDOs are. Yeah, they're a... So the way the voltage on the inside of the LDO works is it has an internal transistor that is... it's a DC to DC converter. But it's a very clean DC to DC converter. And it uses a transistor. I assume they're internal pulsing. It also uses an internal resistor to make sure that the line is held low until it's needed. That way you don't have any voltage leak or anything like that. Let me find this fucking voltage line. Here we go. So PP2V85 2V85 underscore FCAM. Alright, there's the filter for it. We're not worried about the filter. We're looking for the LDO. Where's this fucker at? Oh, it has to be just CAM. It changes names, so I have to do just CAM now. Because it provides voltage for two different cameras on the 6 Plus. Here it is. So, this is an external LDO. So it has VCC main, which varies anywhere from 3.7 volts up to 4.2 volts. As this voltage comes through, it has an enable line that comes from the CPU, and that tells it when it can output onto this rail. So you're taking a voltage that varies anywhere from 3.7 to 4.2 volts, and you're dropping it down to a constant 2.85. Internally to this, you have a transistor that is controlled by some type of logic that will drop the voltage from the input down to what it needs. And then it also has a lot of internal capacitors and an external capacitor here for smoothing. And it just creates a really smooth power rail. But this one's still listed as U2301 because it's an internal, or it's a IC pretty much. Another thing that I've noticed on the schematics, if the chipset is a BGA chipset, it'll be listed inside of the chip. Okay, so it has a voltage reference diode internally. Makes sense. Yeah, the MacBooks do. So I'm going to open up a MacBook schematic so we can look at a buck converter. Let's see. Schematics. MacBook. Let's do 2850. So you have a buck converter on U7000. So U7000 is the ISL chip for MacBooks. It controls the main PP bus G3 hot power. So here we go. So this here is a buck converter. So you have an input MOSFET here, and you have a input MOSFET here. So these MOSFETs are inputting a voltage or a ground outside. So this one has PPDCM, which is the charger voltage that comes through an inrush current limiter. It has two separate MOSFETs that control, they're just open and closed gates. And those are just there to limit the current coming in if it's incorrect. So say everything's good, it comes through here, it runs around there here, goes through a current sensing setup here where it has a positive negative setup that can sense different voltage drops across these to know how much current's being drawn through. If there's a high current draw, your voltage drop will be larger over the distance between the two traces there. So the IC can see that and it can meter that. But to break it down, the voltage comes in here to this MOSFET. The controller goes back to this gate, and then the gate has a feedback through the phase line, and then it has a lower gate which is shunted to ground. So again, you're manipulating electricity. So the voltage comes through. So voltage is coming through here, and it gets to this point and it stops. There's nowhere for it to go. So this gate opens at a high frequency. It opens this MOSFET, pulsing it at a fast rate. And when it opens it, there's nothing for this to say, hey, electricity, go to this line at the output voltage of 12 volts that we need. It may be, since this input voltage is 18, we don't want to just dump 18 volts onto this rail. We want to pulse this to limit how much current is coming through here. So we're going to pulse this one here at a certain voltage, and then we're going to pulse the ground one to create a current draw through these MOSFETs. So as the power comes to here, it'll open this one for a fraction of a second, and it'll open this one at a fraction of a second to make a current draw that pulls the voltage through onto this line. And then the phase line will say, hey, I pulled through 8 volts, we need a little more. So it'll pulse this a little more, and it'll pulse this one a little more. Now we're up to 12 volts. Okay, we're good. Stay at that current pulse, and we'll output through this inductor through this fuse, which is labeled here F7040, and out to the system, where you can see where it says to system. So you can have, depending on how fast these two MOSFETs are pulsed at, you can take a voltage that's lower on the input, and you can pulse it fast enough through a buck converter, a power source, and you can trick the voltage that you need coming through here to whatever you want on your output. If you want a boost circuit, you'll need a diode. On this situation, we're taking a voltage that's already higher than our needed voltage, So we're using these pulses to actually lower the voltage that we need on the output. So if you, I'm trying to think of a way to do it. A good example would be, so you've got a water hose that's putting out like 10,000 psi pressure, but you only want to turn this little pinwheel that's in front of you at a certain rate, and all 10,000 psi is just way too much. It could fucking just blow the fucking thing apart. So what you're doing is you're just pulsing. Yeah, the pulse width determines the voltage. Exactly. So you're pulsing this water pressure through, and you're feeding it onto this little pinwheel output. And the faster you pulse it, the faster that pinwheel turns. So you don't want to fucking just open the fucking thing up, because it'll just destroy it. But if you're just barely trickling it out, like just doing it every so often, the pinwheel may not turn at all. It may just barely move, so you're not outputting enough to it. I'm trying to think of like simple ways to explain it, but that's pretty much all it is. You're just you're manipulating electricity to pulse an output, and then you're using the ground to dissipate the voltage on the fucking inductor. So electricity, that's what's crazy about it. And after I kind of started looking into how it works, you pretty much are just tricking electricity into doing work for you. So electricity always wants a source to ground. It always wants to complete its circuit. It always wants to be neutral. So by manipulating this through transistors, resistors, capacitors more so for storage and cleaning of the voltage, but it's all a manipulation of electricity. And when it fails, when you get a short on a capacitor, you've stopped the circuit before it can complete its task. If a resistor's not working, it may be keeping a signal low. It may be shorting a line to ground. That can happen too. If a MOSFET's not working, you're not allowing that power to go through to where it needs to go. I think a lot of people usually compare it to water, because water kind of follows the same principles, kind of, not exactly, but usually. And water flow is always looking for a path out. So instead of pressure building up, it wants to find a path for releasing. So electricity is kind of the same way. It really wants to be a neutral state. So it's always trying to find an easy way to ground. And by placing resistors or anything on that line, you can kind of manipulate where you want it to go, where you don't want it to go. If a resistor is the easiest path to ground, it will go through the resistor. If it's not, it will stay on the line and bypass it. Yeah, caps can pass AC. That's true. If you look on, here's a good one for speakers on the iPhone. Speakers are an AC signal line. So audio you hear is an AC wave. So if you look on speaker outputs, I need to find that's audio codec. I need to find the actual speaker amp. Here we go. So we were talking about this earlier. If you look on a speaker, let's see, those are voltage sense. We're not worried about that. We're looking for outputs here. Speaker amp to speaker output. Let's see, this should have capacitors in series on it. Let's see here. Zener Diodes. Of course, it doesn't fucking have it. It makes me look like a dumbass. But anyway, so usually on the actual speaker lines, you'll have capacitors that are sometimes in series with the line, and that is to reduce DC noise on the speaker line. A good example of this, and it can also help to smooth out AC waveforms too. A good example of that is in cars. If you're listening to music and you get this like whining noise, you can you can limit that by putting capacitors in line to filter out the AC inductance whine that you hear on the actual DC power supplies. Like, your car technically is taking an AC current and converting it to DC power to charge the system and run the car. It just does it through rectification through the alternator. But sometimes you'll hear on speakers, you'll hear that kind of sound, and that can be filtered out through output capacitors or an input capacitor on the line itself, just to filter out any type of noise. Oh, that's cool. But so, is there any questions? I mean, like I said, I'm sure there's some stuff that I'm completely wrong on there, but that's how I understand it, and I don't know everything, so I'm always open to learning. There is a limit as to what you need to know to do this job, and I think that line is far before you ever get to the level of electrical engineer. I could probably take some engineering classes and understand some of it, but there's other things like for voltage dividers, which use 2 resistors and a ground source, you'll need to have a voltage divider equation. Some people, you can remember it. If you're an idiot and can't ever remember it, you can easily do this and go voltage divider calculator, and you can click here, which is an Ohm's law calculator, and it will show you everything you need to know about that voltage divider. But let's say we've got 18 volts input on our charger, and our first one is, say, 100,000 ohms or 100 kilo ohms, and our second one is, say, 80,000 kilo ohms. It'll calculate our output voltage from that divider should be 8 volts. So if you want to do it by hand, here's the equation: Vs times R2 over R2 plus R1 equals voltage out. So you can remember all these. You can remember Ohm's law. Ohm's law is really useful if you need to like bodge something together. So if you needed a resistor and you didn't have that resistor, but like say you needed a 100,000 ohm resistor, but you only had two 50,000 ohm resistors, if you put them in series, you can get 100,000 ohms. If you put them in parallel, you can get half the ohms. I mean, there's a lot of useful things to learn in electrical engineering, but it's not a necessity to do this kind of job. You do need to have a basic idea of how these work, but you don't have to know the specifics down to the very nitty-gritty. I encourage you to learn those. I'm learning them as I go. When I started, I knew what a resistor was. I didn't know how they were used. I knew what a capacitor was, but I didn't know capacitors could pass certain waveforms through them. I didn't know that they would block certain waveforms. I didn't really know what a coil was. I didn't know how boost circuits worked. I didn't know how buck converters worked. There's a lot of things to learn. But hopefully this helps people out. I'm trying to think of something else I could show. If you ever have a capacitor that's fully shorted, like a very low ohm short to ground, usually components will get hot when they're shorted. So that's something to keep in mind when testing boards. Let's see. Coils and inductors can have lower impedance, which causes like backlight circuits not to put out a higher voltage for a boost circuit. Inductance can cause data lines to get too much noise and cause no image. I've seen iPhone 6 Pluses where the inductors metered correctly, but there was no image, and after replacing them I had image. Oh, diode mode. So diode mode on your meter, I get asked this a lot. And Lewis talks about this. Diode mode, continuity mode, and resistance mode can all kind of do the same thing. Continuity mode usually uses resistance, but it doesn't show a resistance metering until it's below a certain threshold. On my meter, it's about 200 ohms. It won't read anything above 200 ohms. It'll just say OL. But once you drop below the 200 ohms, it'll start giving you an ohms reading. But it also beeps, which is an audible sign, so I don't have to look up and see. So when it reads 400 ohms, and then below that it won't read. You see the latching speed on this thing is fairly quick. That's one thing, a good meter. Latch speed on your continuity test, and the time it takes to delatch are good things. This one's fairly quick. Like, it picks up pretty much every tap there, minus a couple. Diode reading though. So the reason people use diode reading to tell if lines are possibly shorted or not, versus using resistance mode or continuity mode, which can't always show you a short. Diode mode injects a voltage on the red probe, and then the black probe reads how much voltage is being passed through. So a way that you can use diode mode to tell if a component is not reading correctly, if you put your red probe on ground, which is injecting voltage into the ground of the phone, and you come over here and you read, so that's the ground side of the cap. Since my red probe is on ground already, there's no resistance between this probe and this probe because they're both on ground. So I'm getting a 0 volt drop to ground, or pretty much all the voltage is going straight through, so there's no resistance there. But if I come over and I meter the other side, this is giving me a voltage drop across the two probes. So I'm getting a 0.267 voltage drop reading from ground to this side of the cap. So say we were metering a line, and that line is supposed to read, so like backlight output. Backlight output, if it's not shorted, should be around 0.5 volts. So right now I'm metering 0.507 volts drop to ground, from ground to the output of the backlight. If there was a possible issue on the output of the backlight, you could have a reading of like 0.4, which I had one the other day that was like that. It was reading 0.4 volts output, and I had a cap on the output here that was actually partially shorted, and it actually burned up the diode and the coil, and luckily it didn't burn up the IC, but it hadn't created a full short. If I metered that with, say, continuity mode, it wouldn't beep. It wouldn't make any noise because there's no short there that it can read. If I did that in resistance mode, that would work, but you have to hold your meter there. So I'm going to start off, so it reads 9.5, 52 kiloohms, 58 kiloohms, 63 kiloohms, 65 kiloohms, 66, 67, 68, 69, and it's just going to keep increasing until our voltage or our resistance gets up to where it's supposed to be. So if I lift and replace, now it's at 370 kiloohms. Now it's back to 58 kiloohms, and it's just really time consuming. So the diode mode just gives you a fast reading is all it's doing. So instant reading 0.505, click 0.505, click 0.505. If I did that with resistance, I'd be like, wait for it. Is it the right one? Is it close? Yes, that's true. Joshua's correct. So Joshua said that charged caps can sometimes give you a false indication of a short, and that's very true. If you disconnect power and then go and meter a line immediately, sometimes those lines will read short even though they're technically not, because the capacitor's charged. It's completing the circuit, and it's telling the meter, there's a problem. There's a completed circuit here, and there shouldn't be. And so in some situations, I've been trolled by that. I'll meter a line and be like, well, how's this fucking shorted? I know it's not shorted. I just replaced the bad part. And then I'll give the board a second to sit, and I'll go back and reread that, and then all of a sudden the short's gone. And that's because the capacitors had some charge still. ML7475, you're having the same exact issue I had with an iPhone 6 Plus. It wasn't due to water damage, but this one was due to another company overheating the CPU in the Mason area. Mark has seen this before also, and you're not going to like the answer, but you're going to have to pull Cumulus, and you're going to have to meter all your lines under Cumulus and compare them to a known good board. And I'll show you why if I can find it. Tigris audio. It's not up there. It's going to be on down. There it is. So, Cumulus has some lines over here that go to different areas that have resistors and stuff on them that you're going to need to meter. So, you're going to have... Well, first of all, make sure all your power lines are there. PP1V8 grape, I think, is necessary before you'll get 5V1 grape. So make sure that PP1V8 grape is there. But you also have some lines over here that are touch to AP, SPI MISO. I'm not sure what MISO means, but I've seen it before. It's a data line, I'm pretty sure. But you need to check these resistors. There's a couple resistors around Cumulus that need to be within spec for it to work. You want to make sure that your reset lines and your different lines there are all reading correctly. But the best option is going to be to pull Cumulus and then compare it to known good board. What's up, Seven? I saw Wadani posted. What's up, Wadani? Wadani, I think we kind of got his figured out what was going with his. I don't think... No, MISO is MISO. They're data lines. I'm not sure how they work, though. The MISO and other lines can be found on different chips, too. Data lines are still something that kind of confuse me, too, so... Woo, 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 woo. Let's see. Okay, well that's cool. See, Leslie, thank you very much. SPI serial data. Yeah, it makes sense. So it's got directional. So it has a MISO and it has a MOSI, MOSI and MISO. Alright, how can you tell what components are not needed for recovery? Some people knock them off and say not needed. Nate, so that comes down to functionality. In most situations, capacitors are not needed for recovery because what you're trying to do, in some situations they are, but in most conditions, if we're looking for a partial short on a rail, knocking off every cap on that rail can cause some weird issues, but most of the time for data recovery, we're not looking for functionality. So, like if the camera's not working properly, or if the Wi-Fi is not working properly, or something like that, you don't really have to worry too much about those. Now, in some situations, you can knock off enough caps so that there is some problems. Backlight is one of them. If you knock off output smoothing capacitors, you can really cause some issues that cause the IC to burn up. I found that out the hard way. Capacitors are there for 1, smoothing the line, 2, power storage to make sure that your source voltage is not overloaded, and 3, they can be used for AC decoupling or a local bypass capacitor to help with any type of noise on the line. But in most cases, capacitors can be knocked off just to get data. Thanks, Lynn. Thanks, Leslie. Necessary is kind of a loose term, I guess, for data recovery, because in data recovery, your goal is get the information. Who gives a shit if the phone works properly afterwards? So, I mean, whenever I'm doing data recovery and I'm just trying to find a partial short or something, I'll knock caps off until I can fucking find the one that's bad. And if I need to put some back on, I'll find a parts board and put them back on. But in most situations, necessity is determined on the functionality of the phone. If you can get data off with the bare minimum on the board, then everything else is not necessary. Baseband in most situations is not necessary to get data. Audio ICs like codecs or amplifiers are not needed. You can get rid of those. Stay on target. Necessity, I'm trying to think. Backlight technically is not a necessity for data. You can see the screen with a bright light. Touch is necessary for data. CPU, SD RAM, NAND, PMIC, TriStar, Tigris, most of those are needed. I'm trying to think what else. I mean, most of the RF, Wi-Fi you don't need, Bluetooth you don't need, NFC you don't need. There's a lot of subsystems that you can really get rid of and that aren't necessary for data recovery. Technically all caps on the board are necessary, but the phone can function without some of them. It just may not function as well. Anyone had a problem before with no image on a 6 Plus after water damage? Not chestnut, not backlight. No caps or filters connectors blown on stones. No long screw damage. Well, no image. So what have you checked, Michael? Have you checked the AP reset line? Have you checked the Photon Alive line? Have you checked the Chestnut Enable line when the LCD is connected? Have you checked the LCM 1V8 line? Have you checked the LCM 5V7 line? Have you checked the inductors for the data lines? I mean, there's a lot there that can cause no image. It could just be bad FPC. I mean, the FPCs can go bad. You just really got to check everything. So, any more questions? I don't really have any board repairs left. We did. Everything else has been really simple shit lately. I was going to go over the... man, I got trolled super hard yesterday. So, I had an iPhone 6S. Actually, this one right here. I think I got it turned off right now. So this iPhone 6s came in yesterday, or the day before. Worked on it yesterday. It wouldn't charge. So when I plugged it in, I tested it. It would false charge. It would say it was charging, but TriStar wasn't actually working properly. If I connected it without the battery plugged in, it wouldn't bounce up. Alright, Michael. Yeah, make sure image power lines 5V7, 1V8 LCM, AP reset, Photon Alive are both 1V8 lines. Chestnut Enable is a 1V8 output only when the LCD is present. That should be all the power lines to turn it on. Anode, I mean, once you have image, you'll get backlight. If you don't have backlight, it's a separate issue. Does ZXW show layer traces in any way? Yes, it does, but only second layer. So, if we go over to ZXW, any of these that say screw holes are trace damage. So if we click on like the 6+ screw holes, so if you look here, this is the second layer traces on the iPhone 6 Plus. It shows you the screw hole outline and where the traces are in relationship. So long screw damage in this bottom left hole on a 6 Plus. This line here is the LCM to chestnut power enable. If that get damaged, you won't have image. This is a ground line that's not needed technically. That's the 1V8 SD RAM line, which is very important. 5V7 Sage negative, which is touch. An AP I2C line, which is very important. And a LCM to AP HIFA B-Sync. That line is actually the line that causes no touch or the flickering bar on the iPhone 6. If we go over here to the other side, you have a AP to codec, I2S2. That's probably some type of audio for the front mic. Codec to AP, also probably front mic. Front cam I2C line, so that's a data line to the CPU. LCM to chestnut power enable line comes across here also. Did not know that. This one, I think, that's pretty crazy. I didn't know it ran that far. PP1V8 power rail. AP by I2C, it's a data line again. Ground. 45 APU, AP to PMU. Backlight DWI. So that's a backlight, that's CPU to backlight control for the power management, which is PMIC. I'm sure it's some type of power output from PMIC that tells the backlight driver that it's okay to turn on. Same with that one, that's a clock line, that's a data output, and that's another I2C line, data line. Fucking bag of chips is here. You have Maury says, do the baseband voltages come up later than all the other voltages? I think I've noticed that they activate only when baseband is active. Yes. Baseband has its own power management unit. So if you go to the 6 Plus here, alright, so if we go down here to the iPhone 6 Plus, the baseband has its own power management chip, which is right here. If you highlight it, it says U_PMIC-RF. So it's a power management chip for the RF signal stuff. if you go up here and highlight this one, well, if I can fucking click off, this is the PMIC for the top line. It doesn't list this one, but this is the main phone power management chip, and then this is the baseband power management chip, so it's very possible it can turn power on and off. The baseband PMIC is secondary. It comes on after the phone starts to boot, so it can be damaged and the phone will still work, so that's something to look out for. Let's see what else we got here. Check out those lines. I got a weird flickering colored lines randomly appearing every now and then. Michael, are you talking about for the no image phone? If you have weird flickering colored lines, I bet your 1V8 LCM line is down. Can someone come over and drag this 2x12x14 beam to the attic for you? Unfortunately, no, Bobby, sorry. I have an iPhone 6s with a short in the USB port near to the left mic, boot looping. Changed the charge port flex, restored it. It finishes, but it boots into recovery mode, iTunes, needed. If it's in recovery mode, try an update, software update, and see if it will fix it. Software update will not delete anything, only a restore will delete information. All these foodie names getting hungry. Cheeseburger and chips. Missing VREG SMP S1 0V9. The phone is in DFU mode, so it won't actually accept the software because of baseband error. Oh, yeah, that sucks. So baseband errors only become an issue if the phone is in recovery mode. The phone will not restore with baseband being faulty. The only way to fix this is you have to fix the baseband problems first, and then you can get it to restore. What is the thickness of your iPhone 6 PMIC stencil? The one I have seems to buckle under heat. I mean, mine will warp a little bit, but thickness 0.12. I don't know what that means. I mean, it's fairly thin. I don't know if you can see it, but I mean, it's a little thicker than some of them. The amount of heat that you're using will make these buckle differently, so if you're getting a lot of warping, turn your heat down and see if it changes. Any fixes for my back? Someday I just want to end this painful life. My girlfriend's mother has really bad back problems, and she's in constant pain too. The only thing I can suggest is possibly some green herbage that you can inhale to take away pain. Chat names make you bust out in laughter. Yeah. Definitely check 1B8. Yes, check 1B8 for sure. No image. No image phone. Okay. Bag of chips is Chris Long's #1 fan. I don't know about that bag of chips, so we're gonna have to see. We'll see if you're #1 fan or not. Good morning, Big Black Dick Joe. How you doing, Joe? Keep it PG, bro. Some of the names, man. Acupuncture, yeah, that's a good one. Pressure points are a good thing too for pain relief. Alright, so anybody got any more questions before we end this one, before Big Black Joe gets excited and we're all fucking in a bad situation? I would go to hell if I do, but Doc's safe. And that's something they want me to touch. They don't want you to touch weed. And it's better than pain pills. How do I hold the stencil in place? So, what I do, let me find an IC here. flux going everywhere. I love it. People on the internet are funny. You gotta find that fine line between funny and annoying, though. Because when you step into annoying land, then it just becomes a nightmare. Alright, so whenever I do my stencil hold down, this, I'm obviously not cleaning this or anything, but when I've got my stencil laid and I've got my fucking solder paste down, I just put my tweezers to the outside edge of it and then come in, heat it up slowly. You don't want to just fucking like come in here with a 1,000-degree torch and blow everything away. I usually try to heat it slowly so the flux will burn off a little bit, and then come in, reball. Once it's done, lift your stencil and just push out the IC until it falls free, and then you're done. Put too much heat on NAND and shorted the CPU. Can I remove CPU and reball it to get it working? Nate, you can. It's just really difficult. It's completely possible, but it's a difficult repair. Mostly not. You have to be very precise as how you remove the chip, because if you heat the chip and you try to pry it off, you can warp the chip. Warping it will cause it to where it won't sit down flush, or you can actually break it internally. And the other issue is reballing the chip. The CPU is such a large chip and has so many small BGA components. It's really hard to get a proper reball on them. It takes a lot of practice to get. There may be some people out there that are just naturally fucking skilled. But Bag of Chips is hungry now. Since we've been talking about balls. For pain, I have Soma and morphine, but I hate these. They're dumb me down bad. Yeah, I mean, that's what, like, my girlfriend's mom, they tried to put her on a lot of opioids and stuff, and it's just, she doesn't want to be on them. She lives in pain constantly. She sleeps like a cat. She just naps for a little while before it gets too bad. And the only thing that's really helped her is, honestly, like, we started she makes her own THC butter pretty much, and it helps dull down the pain and allows her to eat, and it honestly allows her to sleep some too. I just subbed to your channel, big man. Keep up the good work. I appreciate it. I take Lycra or Lycra. I mean, I was talking to Paul this morning, and he was talking on his channel about healthcare systems, and it really sucks for, especially in the American healthcare system, like how much we pay for everything. Paul was saying that if you wanted like the top of the line fucking insurance in Australia, he was saying that his insurance premium would be around $200 a month. I would fucking love to have top of the line insurance in the US for $200. I feel like Bag of Chips and Big Black Dick Joe are just the same person on two different accounts. Colonoscopy was $13,000. Goddamn. Yeah, my girlfriend went to the ER the other day because she almost passed out. No problem, Mark. She almost passed out the other day and had some like hearing loss, and I was just kind of worried that maybe she had some blood pressure issues or something going on, and we wanted to make sure, because she's had like heart murmurs before, and she has very low blood pressure to start with, just naturally. So we took her in, and they did an IV, they did urine work, blood test, and an EKG, and we were there for a few hours, and it costs $5,000. They charged her for the piss test, which tests for drugs and pregnancy, which didn't fucking matter because we weren't there for that. And they charged her $360 for a pregnancy test, and $600 and something for the drug test. And then on the blood work, they ran everything. They gave her 4 different antacids because they thought that she had acid reflux, and that might be causing some of her issues, which I don't understand. But they gave her 4 different antacids, like Tums or something, but some over-the-counter stuff too, and some prescription stuff, which totaled to be like fucking $1,200 in antacids. And the EKG, which we looked up, the EKG strips, the exact ones that they use, because I looked at the brand, the exact ones that they use with the exact machine that they have. The strips are 500. It's a 500 box set. You can buy it for, it's like $200 or something like that for 500 strips or something like that. And the machine itself that they have costs $2,600 new. It's not Obamacare. That's a misconception. I mean, Obamacare may have driven up some insurance costs, but our medical costs in general are fucking exorbitant. Like, that's why insurance in other countries that have single payer systems are lower, because they mandate the prices of the cost of goods in the medical field down. And we just kind of get short end of the stick fucking on that stuff. No problem, Martin. I mean, Obamacare has gotten a bad rap because it's not been efficient, and I agree with it. It has not been efficient because it's not done everything that it's promised to do, and I think that it needed to be changed. I don't think it needed to be thrown away, but there is more to it than just Obamacare is bad. You have to start from the bottom. Where do your costs come from that insurance have to pay for? Insurance isn't there just making money because they want to make money, which they do make quite a bit of money, but they're paying for a cost that it costs to treat you. So what goes into the cost of treating you? Hospital costs, doctor costs, and medication costs. That's the 3 bigger things. So your hospital includes the place that they're at, the people they employ, and the tools and stuff they use. The doctor's cost is how much the doctor's charging. And then the cost of your expenditures, like your prescriptions, your over-the-counter stuff, your test strips, whatever, blah, blah, blah. So, like, the thing that runs up insurance costs to start with is that. Hello.
You're my daughter's DS again? I think she dropped it off yesterday or something.
You go find it.
Thank you.
There you go.
Oh, thank you, Joey. Anything
Nope,
else?
you're good.
Thank you so much.
You have a good day. So, insurance is a bigger thing than it's usually made out to be. A lot of people think that Obamacare coming in, so it forced insurance companies to provide service, so that drove up prices. Well, no offense, but medical insurance in general is it's not an insurance. You're going to go to the doctor. I don't buy car insurance because I know I'm going to wreck. I haven't personally had a wreck, and I don't know. I don't think I've ever had a wreck that's been my fault. But insurance is there for a just-in-case situation. And health insurance is not a just-in-case. You will 100% guaranteed, unless you just choose not to go to the doctor, you will have a situation in your lifetime that will require you to seek medical care. It's just a fact of life. Be it you make it through your whole life and you're about to die, you're still going to at some point be in a medical institution, unless you just choose to live in a situation where you don't go to the doctor and you just live with what you have. I mean, and a lot of people have to do that when they can't get insurance coverage. So to me, insurance is a necessity that's sold as a precautionary, and that in itself is bullshit. personally, the way I feel, and it may be wrong, I feel that insurance should be a non-profit organization. It should be done for the purpose of helping people deal with the costs. I think if we can get our costs down, we can greatly decrease the cost of insurance. And I mean, I don't know. For me, Paul's, like, talking to Paul, like, Australia, you may pay higher taxes on other things, but I mean, fuck, we spend, in America, we spend, what, $500-something billion a year on our military. I mean, I think we should take care of our military people, but at the same time, I don't think we need to perpetuate war either to require those costs. So we're going off on tangents now. But yeah, cost is the source issue. Insurance and everything else is secondary. So fix the costs up front, and everything else will fucking come down. Period. Just how it works. My inhaler that I use, my rescue inhaler, let's see if I can find it. If I have it on me, it might be at home. I don't need it very often, but my rescue inhaler in the US without insurance is $80 a piece. In Canada, in Cuba, in Mexico, in fucking Australia, anywhere else, the same exact inhaler is $8. So why do I have to pay $80 for an item that you can buy anywhere for $8 from the same exact manufacturer? My inhaler is made in Australia. It literally, I can buy it direct from Australia from the manufacturer for $8, but it costs me $80 here. So anyway, I think that's gonna pretty much wrap it up. I think that healthcare is something that's going to take a while to change, and I don't think that the current situation that we're on is a solution. It's going to end up putting more people off healthcare again, which may lower the premiums because insurance companies don't have to cover those people, but at the same time, morally, are you okay with telling people to go fucking die? I'm not, personally. I wouldn't want to tell somebody's family member, fuck you, go die, I don't care as long as my premium's low. But how's the EMS run here? EMS is run by the hospital. The hospital charges you, and most insurance companies do not cover EMS. Fire departments are paid for by the city. That's paid for by your state taxes. What up? Or your city taxes. EMS, though, is based off of the company, or off the hospital it's run from. And it is expensive. You know how much an EMS ride is? I don't remember.
A what?
EMS ride, if you call the EMS to take you to the hospital.
Oh shit.
It's a lot.
$1,500.
Yeah, it's like $1,500. But the fire departments are based off of our city taxes. Those are not, you don't pay anything for those. That's the socialism working in America that's so terrible. Just like our fucking roadways that we drive on. Why do I have to pay for roads over in South Warren, Kentucky if I don't drive on them? Not here. The EMS here is run by the actual hospitals. All the hospitals here have their own EMS services. I think they're subcontracted out to the city though. But like, there's a place here. It's a medical center. They have their own EMS. They have an EMS over at the other place called Greenview. It just depends on where you go, I guess. Yeah, $2,000. Yeah, some expensive fucking gas in those EMS trucks. Why you pay taxes on the Viking Stadium? I see it, and I can understand why somebody's pissed off about that too. I mean, but I think there's a lot of things that we pay taxes on that are much more infuriating than if Joe Blow goes and fucking gets food stamps for free than other things. So I think there should be checks in them. I don't think we should just allow abuse, but at the same time, if you showed me two different things and said, hey, we just spent $14 million on the jet, or hey, this guy got free food stamps and he shouldn't get them, I'm probably going to be pissed off about the jet more so than I am about the guy that gets free food stamps. Oh no, there's plenty of opportunity in the United States. It's just, there's also a lot of bullshit too. I mean, I pay a lot of taxes as a business owner. I pay taxes for the business. I pay personal income tax. I pay taxes on stuff that I have to buy. I mean, we pay income tax, pay business tax, pay purchasing taxes. We don't pay food tax here. We pay gas, anything other than food, property, housing, water, like just fucking everything. You pay taxes on a lot of stuff. Yeah, TCRS. The EMS are subcontracted by the city, but they also work directly for the hospitals. And the fire departments are all city run. There's no independent ones. We don't pay taxes on food. Move to Europe. See, I mean, a lot of people will say, and I know you didn't mean it in this way, but a lot of people in the United States, if you complain about stuff, they're like, well, if you don't like it, move. Well, it's not really a viable argument. If you don't like it, doesn't mean you have to just accept it. Fucking change it. That's like saying, well, if that kid doesn't like being raped, then maybe he should run away from home. No, maybe you shouldn't allow the raping to happen. Custom charges will deter you from that. Yeah, that's the thing. Like, Paul pays a lot of money on stuff he imports, but I mean, is that necessarily hurting? That kind of hurts the consumer more so than it does any good to promote internal production of things. That was another thing a lot of people argued about, is if they raise tariffs on goods coming in from Mexico or China, then that'll promote businesses to make stuff in the United States, but that doesn't hurt those businesses. That just hurts the consumer because they pay a higher price. Maybe it makes it more competitive to make it in the U.S., but if you don't have the infrastructure already available for it, it's still going to cost a shit ton to even get it started. And at the same point, you're not saving any money at that point. You're just charging people higher costs for the same goods.
Hey, Chris, if I give you money, can I use your Amazon?
Amazon? Yeah, you can use my Amazon. My Amazon. It should be just log in on Ashley's.
Alright, that's what I was going to do.
Just make sure you pay with my card. That iPad's right there.
Which one's this? Oh, that's hers?
I think my taxes come out to be right in the 20-something% range after everything's said and done. TCRS, did they just pass? Well, they didn't pass it, but it got through the first voting process for single-payer healthcare system in California, didn't they? I thought I heard about that.
You want the money or you want me to put it in the drawer? It's what I'm ordering is $93.
Fucking A, man.
Maybe 100.
Either way,
Okay.
I don't care.
I'll just take, what is it, $7 out of your chain.
I mean, here's the thing. Like, I get where people are coming from when they talk about why do the wealthy have to pay more taxes? It's not fair. And yeah, I can agree with that. It shouldn't be that you should be taxed more if you make more, but at the same time, that's where the argument comes in. at what point is there a moral obligation when you have enough income? I try to give as much as I can to just local things, anything that comes through here. We have a lot of people down here that are, I don't know if they're homeless, but they beg a lot. So I mean, I give away a lot of money to that. We give to charities, we give to local events. Not just for publicity, but also because I like to give back to the community and help out. I've been really poor at times too. I mean, there's been times where I've had maybe $100 in my bank account. So I think morally, if I have enough money to give back, I have no problem in doing so. As long as it doesn't risk the comfort of my life and knowing that I can afford the things that I need, then I have no problem with it. If it benefits somebody else. I don't want to just give money to the government so they can just go throw it in a hole and burn it. So Jesus does work with me. Say hi, Jesus.
I'm Jesus.
Hi, I'm Jesus.
Ready for the second coming? I am.
Second coming? Which coming are you talking about?
It's like it's a laugh.
Bobby, it does beg the question, how much is too much? And I reference this a lot. If you go back in U.S. history, in the 40s, 50s, there was a tax that was called excessive wealth tax. So it's at one point morally the U.S. felt that there was a point in which wealth was too much. Not necessarily too much, but you had enough that you weren't going to struggle, you weren't going to die. And I feel like that kind of value is gone. Now we kind of, I mean, I don't get me wrong, I enjoy having enough wealth to not have to worry about things and not have to want for anything. But at the same time, I think if I was making, I mean, what is it now? The cutoff for the top, it's $250,000 a year. I mean, if I was making $250,000 a year, I don't think I'd have any issue. Like income tax, $250,000. We might, as a company, gross like close to $200,000 or 100 and something thousand, but actual income tax, like income take home, I don't make that much because a lot of the money that I get goes right back into the company. So I think if I was actually bringing home $250,000 in my pocket and paying taxes on that money, I don't think I would be struggling at all in life. And if I'm pissed off because I can't afford to buy a private jet, I don't think that that's something that necessarily is a need. So I don't know. Whatever. Yeah, I agree. Wanting and needing is relative to the person. It's a very delicate thing. I don't fault people for wanting to gain wealth because it's a security thing. But I also feel there's a moral obligation that comes with having more than everyone else. Like, you should want to try to give back. I'm not saying go out and just give people money, but give opportunity for those people to gain. Double taxation with the U.S. Capitalism is only effective in free market, not free when corporations are writing the laws. Capitalism, a pure capitalistic society is not. It's not good for all people. Pure capitalism creates a very poor class of citizen that can. It usually means that you have a survival of the fittest situation in capitalistic societies, pure capitalism, because if you can't make it or you don't get the same breaks or don't make it like somebody else does, you're fucked. Plain and simple. The highest tax bill is 2.7. They actually, the wealthy in the United States actually pay a fair amount of the taxes. They actually pay more than what they actually make up, but they also have the majority of the money. So it's I don't know. It's a weird. There's got to be a balance there. I don't think the tax system is terribly unfair because everyone pays the same amount of taxes per income bracket. You only pay the highest percentage on income over $250,000. So it's not unfair in the sense that you pay more taxes technically. You just pay higher taxes at a different point in income. Does ZXW have the baseband classic? What? The fuck are you talking about? Trump is going to give so much more money with taxes, and when we rich folk talk, really don't need it. Well, I mean, Trump is looking out for his own personal interests. I mean, that's... Oh, the BlackBerry Classic? Oh, let me see. They have Blackberries on here. HM1, I don't know what that is. I guess, yeah, that looks like the BlackBerry Classic. I don't fucking know. I don't work with Blackberries. Trump's looking out for his own personal interest, and I mean, I don't like him, but at the same time, I can understand why. I mean, fuck, everybody is. You're not. The number one is always yourself, and then the secondary is somebody else. So, I don't agree with him, but at the same time, I can understand why he would lower taxes for himself. I mean, that's kind of a no-brainer. TCRS, you can't make fun of me and then not know what HM1 is, bro. It looks like the traditional BlackBerry. I mean, it's got the keypads down here. This is the keypads. This looks like the IC controller for the keypads. Oh, maybe not. Oh, no, that might be that little fucking track point thing that you push around. Yeah, I mean, I know there's a lot of write-offs to the rich. And that is kind of unfair to the poor because, well, it depends, I guess. The poorest in America don't pay any taxes, so they don't really have to have a loophole. But at the same time, who the fuck wants to make $14,000 a year or whatever the fuck poverty level is, $16,000 for a family or something? Like, that's not, you can't live off that without being like constant edge of dying, or constant edge of if something goes wrong, you're fucked. Let's see, on our day-to-day... Well, I wish I made that kind of money, Paul. I don't. Honestly, I don't even know if I would want to make that much, to be honest. I mean, I think at some point money becomes a burden, almost.
Like that sticker on your elbow?
Like the sticker on my elbow right here. This burden. I think having too much money, it becomes a burden on you, because then people look to you and they say, well,
give me money.
Give me money. I want some money. You've got so much. And
they do that to me even though I don't have any
yeah,
money.
Micah doesn't even have money. Jesus over here doesn't have money, and they fucking ask him for it. He does feed the poor, actually.
The poor feeds the poor.
Yeah, pretty much. I don't know. I hope one day that I can build a business that's successful enough that I can retire and not have to worry about things, but if I have to work the rest of my life, then so be it. Can Jesus multiply bread or fish?
Fish.
He can only do fish. We still have no iPad Pro schematic, that's true. Let me see. Let's see what they have up there. They have Mini 4, and they don't have the Pro. It's weird that they don't have the Pro yet. This one's probably not labeled. Yeah, it's not. Yeah. See, the iPad Mini Pro 4 is not labeled. This layout's very similar to the 3, though. That's your battery gate. Goes through probably some inductors or something. Let's see. Oh, there's the battery gate. So that's got to be some type of power for the touch or something down there. Oh, you're talking about Spoons? Yeah. I get Spoons is a good guy. Like,
He hasn't been here forever.
yeah, he hasn't. I've seen him out on the square though.
Yeah, I see him every now and then. Yeah.
Spoons he's supposedly a war veteran, and I think he is.
He has a house.
Yeah,
He's not exactly homeless.
Well, he's not homeless, but he kind of is. I don't know.
Yeah.
He lives with another guy that's disabled, and Spoons is a really good guy. I think Spoons has gotten to a point in his life where he's kind of given up on trying to do anything worthwhile, and like he enjoys just talking to people. He likes to sit out there and he plays. We call him Spoons because he actually plays spoons. Like he makes music with spoons, which is kind of a
Spoon
hillbilly
man.
thing, I guess. But I don't know. As a person, he's not somebody that I feel is overly dishonest, and I feel like he genuinely means good, so I have no problem in trying to help him out, or not really necessarily help him out, but just like if he needs something or whatever, $20, whatever, who cares? I mean, I've given over $100, $200 to him over the time I've been here, which isn't much. We've been here a year and a half, but he used to steal our pins. He stopped now,
Now you
though.
can see that we have a large array of pins in the bin.
Yeah, so I think he stopped stealing the pins. I think he's got enough pins, but well, not stealing. We give them away, but he would take more than a normal person would use.
He would take at least 8 at a time.
Yeah, he'd take like 6 or 8 at a time. But I don't know, like if I see somebody that genuinely looks and I feel like they're actually in need of help, or they're a good person and they're not just out fucking jacking somebody around. Like people that come up and lie to me and say, hey man, can you give me some money for some gas? And then they don't buy gas, like fuck off. But Spoons, he's just like, hey man, can I get some money for food? I'll give him some money and then later on I'll see him with food. I mean, he's not lying about it, so. I'm sure every now and then he might buy himself some booze, but whatever. Go do your thing, man. I'm giving you money. You can do whatever the fuck you want with it. So. I think everybody at some point needs some help. Or just somebody there that will try to give them something, even if it's not. Lewis kind of looks at giving as a family or friends kind of thing, which I can agree with. I think that you should have family that's there to help you and friends that are there to help you. But at the same time, I don't think that means that nobody else, even acquaintances, can't help you. So. But anyway, my voice is about worn out. I've been talking for 2 fucking hours straight. I don't see how Lewis does it. I guess he takes breaks. But I'm gonna get off here. I appreciate everybody watching. I'm still debating on if I want to get this PC3000 flash shit. I really need to, I guess, because I've got some jobs to do, but I really worry that it won't pay for itself, so I'm going to throw that around. I'm going to see where the bank account's at and see if I want to throw $2,000 towards a piece of equipment that I might use once a month. But thanks for watching, everybody, and if you're not subscribed or you know somebody that might benefit from the channel kind of learning, let them know. And we've got the affiliate links and stuff down there at the bottom. If you all want to buy something and you want to use my link to go buy it, you don't have to buy what the link's attached to. You can search for something else. We appreciate it. That money is going to be put directly towards buying the equipment for like the PC3000 stuff. And hopefully we can make some cool, interesting videos on data recovery. Paul, I appreciate it. I'm not really asking for a handout. If you all want to buy something or whatever that helps me out, that's cool. But I really don't need a handout on it. It's just I get like nervous, I guess, when I spend money, even though it's not like I'm struggling for it. But at the same time, I want to build up the business and I don't want to make bad investments. So for me, $2,000 is still kind of a big thing for me, but hopefully one day it won't be. But again, if you all want to buy anything through the affiliate links, it kicks back to me a little bit. If you all want a t-shirt or anything, I need to make some more. I've got some more that I need to make. I may do that now. But thanks for watching, and you all have a good day. We're going to close this out so y'all can see the tunnel effect. Later.